Welcome to Pomodoro Joe for Wednesday, October 11th, 2023. Today we're looking at LeetCode problem. You gotta be kidding me. 2251, number of flowers in full bloom. This is another hard problem. This is the fourth hard problem in the past 5 days. Come on, LeetCode. You're killing me here. How am I supposed to get my Hacktober project done when you keep throwing hard problems at me? Okay, what is this one? We are given a zero-indexed 2D integer array of flowers, where flowers index I has a start and an end, meaning the I flower will be in full bloom from start to end, inclusive. All right. You are also given a zero-indexed array people of size n, where people index I is the time that the ith person will arrive to see the flowers. All right. Return an integer array answer of size n, where answer index I is the number of flowers that are in full bloom when the ith person arrives. Okay. All right, then we have some examples here. Looks like we have blooms that start 1 and go to 6, so that's this one up here. Then we have a bloom that goes from 3 to 7, so that's this one here. 9 to 12, where is that? That's over here, 9 to 12. And 4 to 13, and that's this one down here. Cool. Then we have people that show up at 2, 3, 7, and 11. So 2, there's only one flower in bloom. 3, we got 2 in bloom. 7, we got 2, and 11, we got 2. So it looks like it would be 1, 2, 2, 2. All right. Okay, I think I get it. Now let's see. Let's look at some constraints. So the flower length, or the number of flowers, is from 1 to 5 times 10 to the 4th, so that's pretty reasonable. Flowers, each element has a start and an end. Let's see, but the start and end times can be anywhere between 1 and 10 to the 9th. So my initial thought was, let's just create one big array and we'll keep track of all the time slots where there could be flowers. But with 10 to the 9th, I think that's too much. I don't think we'll be able to allocate that much memory here. Then we have people up to, let's see, 5 times 10 to the 4th number of people. Okay. So we'll put 25 minutes on the Pomodoro timer and we will get started. I think my plan here will be to, since I can't keep track of all of the times, I can't just have one array that keeps track of all the flowers at any time slot. I think what I'll do is just keep track of the important events. When were flowers starting to bloom and when were they ending their bloom? I guess if you think about it, it's like once you know where a flower starts a bloom and ends a bloom, then how do I put this? The number of flowers in bloom will only change at a start or end event. Anything in between, it'll just maintain the same number of flowers in bloom. So we don't need to keep those. We just need to know where these events happen. Flowers bloom or they stop blooming. All right. So let's see, I'll have some mapping here where, what do I call this? I just want to keep track of the important events. So I'll say bloom events. All right, and this will be a dictionary. Let's see, I'll have a default dictionary of ints. So essentially this will be the deltas that happen. The int will be the flower. If it's blooming, it'll be a +1. And if it's not blooming anymore, it'll be a -1. All right. So then for every flower in my flowers, all right, so this has a start and an end. So we'll have a bloom event at the start. Let's see, that's going to be flower index 0. And let's see, we'll add 1. One more flower starts its bloom. Right, and then we'll have a bloom event for this flower. At 1, it's going to end its bloom. So minus equals 1. Cool. And actually, hang on. So the flower blooms from start to end inclusive. So that means it's still blooming at this point. So I don't want to subtract this one until the next time unit. So this is actually going to be flower index 1 plus 1. That's when it really is done blooming. All right, so now I have my bloom events. These are the important things that happen, the important blooming events. All right, now that I have all my events, I kind of want to know all the different times, and I want to sort those times so that when I'm looking for a person's arrival time, I'll just look in this list of important events and find, I guess, where their arrival time lands. If it's between important events, then I can figure out how many flowers are blooming at that time. All right, so now I need my event times. That's just going to be, I want them sorted, so I'll do a sorted list of all the bloom event keys. All right, so the bloom event is a dictionary. Its keys will return all the keys into the dictionary, and those keys are the start and end times for my blooming. And I'll sort them so that I'll have them in an order, which means that when I'm looking for a person's arrival time, it should be easier to find in my event times. Let's go through and actually calculate the number of blooms for each of these event times. So I'll have a bloom count. Let's see, it's going to start as an empty array. And then for every event in my event times, now the event itself, actually this is an event time in event times. So I'll have to look that event up in my bloom event. Is there a better way I can do that? I kind of don't think so. All right, so this is the event time in my event times. Now I have to look up the event type, or I guess it's the bloom count for this event. And that's just going to be equal to the bloom event at this time. All right, and now I need to take my current bloom count and adjust it by the bloom count for this event. Maybe I should just call this bloom delta. Well, that's all right. So now my bloom counts, append, let's see, it's going to be this bloom count plus the previous bloom count, but I might not have one if it's empty. So let's actually keep a separate variable here that's like blooms, and we'll set it equal to 0. So then my blooms will change by this bloom count, and now I can just append my blooms. All right, so we're going through every one of these bloom events. We grab its time, we're gonna look up, well, what happened? Did we get more blooms or did we lose more blooms at this time? We'll adjust our bloom count. Actually, I did this a little bit wrong. There we go. We'll adjust our current number of blooms by the change that happened at this event, and then we'll add that to our current bloom counts. So now we have a list of all the blooms, and they correspond to these event times. All right, now we just have to go through all of our people, find out how many blooms were happening at their time of arrival. So I could go through and I could basically look at their time and then have another function that looks up essentially finding their time in this bloom counts array. But that could be expensive. I'll have to essentially go through all the times either linearly from start to end, looking for the closest event that happened before their arrival time to see how many flowers were there at their arrival time. Or I could actually sort all of our people by their arrival times, and then I can just go through the people one time and not have to go through this like lookup of how many blooms there were at a given time. So I think I'll do that. Let's sort our people. Unfortunately, I need to keep track of my people at the right index, so I have to keep track of their indices. So I'll have like sorted people here. I'll do a little bit of a shortcut. So I need to know their time and their index. So that's in their time and their index for every index and time in the enumerated people. All right, and I do want to sort this, and I'm sorting it by time. So let's sort it here. Okay. All right, so now I've got a list of my people, and they're sorted by their time, but I'm also keeping track of their index so that I can put them back into our result array when we get there. Actually, let's do that now. Let's create our result array. So we need some result array, and let's just set it equal to 0 times, let's see, the length of people. And then we'll return our result at the end. Okay, so we've got our sorted people, we've got our result, and now we actually have to go through and keep track of how many blooms there are. And I guess we'll go through all of our people and keep track of how many blooms there are and what event we're on. So I guess we need to kind of keep track of our event time right now. So event time, I guess it's not really the time. I need the index into my event times. Maybe I'll call it current event, or I'll just call it event index. Okay, so the current event is at index 0. Now for every person in our sorted people, so this person's time is equal to, let's see, person, and I'm sorting by time, and they are at this t, so that's going to be index 0. Now I need to check, did this time happen before or after my current event's time? So what I'm looking for is the last event that happened before they arrived, because I need to know how many blooms are actually blooming when they arrive. So I have to find the event that happens before their arrival. All right, so that means I need to look for, let's see, well, this event index. So now the index will index into my event times here. So I need to have this index less than the length of event times. And my event times at this event index, whoops, has to be less than my current person's time. Okay, so while it's still less than a time, we'll just advance this index. But that means that once it reaches their time, we might have stepped one beyond their time. Actually, it looks like I probably need less than or equal to. So even if we get to their time, we'll take one extra step. So now we've stepped one step beyond the time, so we have to actually take a step back. Oh man, this gets complicated. Okay, so we figured out the event that happened basically closest to their time. Now we have to take one step back to find the event that happened before their time. That's going to be event index minus equals 1. But now this could be a 0, so I don't want to go down to -1. So let's make sure that we have max of 0 or event index minus 1. So now we don't go too far. We don't go out of bounds. And then we can get our result. So the number of blooms, that's going to be our bloom counts at this same index. So remember, our bloom count array and our event times are synchronized. They share the same index. So the number of blooms at this index matches this event time. So our bloom count at this event index. And then we can just add this to our result. But it's not just our result that we're appending. We actually need to get this person's index. So I have to say person at index 0 or index 1 here. And now we can set this equal to the blooms. Okay. And then we do return our result at the end. All right. I think this is pretty good. One concern. So one thing that I'm worried about is what if, so if our very first event happens, I I guess, after the very first person arrives. Let's say the first person arrives at time 0, but our first event is at time 1. Then we'll actually be reporting time 1's event, like there was a bloom, even though there wasn't, because the person arrived before our time series started. So I think I might need to actually add an extra 0 to the events here. Let's see. Yes, I think I do. My event times have to start at 0. And then I'll append the rest or extend the rest of the event times after that. So this will help us get to the right bloom count. Oh man, let's run this, see how we do. All right, bloom event, plural. Wonder if I made that mistake anywhere else. Let's see, bloom counts, bloom count, bloom counts. Yep, I did it here too. Bloom events. Okay, let's try it. And it doesn't work. Let's see, we got 1s when we should have 2s. So where did we go wrong? I think we're missing, probably off by 1 here. This should not be minus equals. There we go. I started to do minus equals 1 and replaced it with this max. All right, let's try this. There we go. Okay, we'll submit this, see how we do. And we pass. Let's see, we don't do great though. We only beat 46% for runtime and 69% for memory, so not great. We can jump back here and try to clean this up a little bit, but I think there's probably just a better way to do this. Well, one thing we could do, like this blooms we don't actually need because we're just assigning it here. So let's do this and clean that up. What else can we clean up? We don't need this time. We can do that. Although that might actually not help us. That might slow it down because we're going to be grabbing this multiple times. What else could we do? We could make our own max here. Sometimes I like doing that. Let's do this. So the next event index will be event index minus 1 if event index is greater than 0, else 0. That might help us. All right, let's see if this makes a difference. Not really. We're still about 46% for runtime, a little bit better in memory. All right, we have 7 minutes left. There is a better way to do this, but it's a little bit harder to explain. So let's start this whole thing over and let's see if I can explain it in 7 minutes. So here's the plan. We go through, we just find all of the start times and all the end times, but we keep separate arrays. So we have start times, and that's just going to be an empty array, and we'll have end times. That's also an empty array. So then for every start and end, so this is start of the bloom and end in the bloom. So for every start and end in flowers, there we go. We'll just add our start to the start time and our end to the end times. All right, so this is all of our start times in one array, all of our end times in another array. Now let's sort these. So start times, sort, and end times, sort. So this will be sorting these from low to high, but as long as they're sorted in the same direction, it should be fine. So the plan here is if we find a start time, so if we have a people time, we look for the closest start time that is actually after their arrival. And we look for their closest end time that is before their arrival. Now, the number of flowers that exist at this start time is actually the index of that start time. Because for every event, this is all the events, for every event, one new flower blooms. And since these are sorted, it means that all the flowers that came before this one would have bloomed before this one in time. So if we had an index, start index, let's say of 10, that means 10 other flowers have bloomed before this start time. All right? And similar with the end time, if we had 5 end times that happened before this particular time, that means 5 flowers stopped blooming before this time. So we can take the start time, the total number of flowers that bloomed since the beginning, and subtract the end time index, the number of flowers that stopped blooming, and that gives us the total number of flowers that are blooming at this time. So now we just have to have some result here. We'll just have an empty array. We're going to return our result at the end. Now we go through every person in people. And for this, we need to find the start time and the end time index for this person's time, for this time. So to do that, we could do a linear search. We could actually go through and find our start time by just saying while start time, or start time at index I is less than this time. I'm going to actually call this time. We're down to 4 minutes. But since these arrays are sorted already, we could do a binary search. So we can actually do a binary search, look at the high and low, split, find the midpoint, check it, etc., etc. That's all awesome. There's a faster way to do this in Python, and since this is a hard problem and I don't have a lot of time, I'm just going to use the shortcut by using the bisect. So bisect will actually do the binary search for me. So let's get the start index by doing a bisect. And now I have to choose if I do a bisect left or a bisect right, meaning do I want the thing to the right of this element that I'm looking for, or do I want the element to the left of the element that I'm looking for? Now in our case, with the start index, I want to find the start index that is after this person's time. So it's going to be a bisect right. Okay, and now we have to pass in the array, so this will be start times, and we have to pass in our target, which is time. That's our start index. Now our end index will be similar. We're going to do a bisect left though, because we want to find the last index, the last end event that happened before this person arrives. It's going to be end times for this time. And so now our blooms, that's just going to be our start index minus our end index. And so our result will just append these blooms. All right, so I think that should do it. We're down to 2 minutes. Let's run this, see how we do. Let's see, index out of range. Oh, of course, I need to append start. All right, man, I'm gonna run out of time on this. Oh, and it works. Let's see if we can pass all the tests. And we pass. And this does much better than our other algorithm. Now we're beating 74% for runtime and 22% for memory. So yeah, that's a win. Now I'll point out we do worse in memory, and I think it's because this bisect probably takes up more memory. We could do our own binary search here if we wanted. We might be able to save some memory on it, but the ease of doing this bisect, I think, makes up for this extra cost in memory. All right, I am down to a minute, so I am done with this one. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.